So this is the final video in the P1 section of the revision videos, and the final thing we need to do is know about how to describe waves and how to do some calculations using the wave equation. So the first thing that's really important you can do, because this comes up on so many GCSE questions, is to label a wave. Now you might be given, or you will be given, a diagram that looks something like this. Okay, so this is what a typical wave looks like in people's heads. It's a normal wave. Now, you need to be able to label it with two things. I'm going to draw in first, just to help us out, a kind of central line. And this is where the wave, this is like the middle of the wave. Okay, this is going to help us, and you'll see why in a second. It's a bit wonky, sorry. So, you need to first be able to label the amplitude. Now, the amplitude of a wave is the distance between the middle of the wave and the top of the peak, or the bottom of the trough. And it's measured in meters. So this one here, this is my amplitude. It is not this. Okay, this is double the amplitude. This is not the amplitude in any way. That's two amplitudes. The amplitude is this one. That's really important. The mistake that most people make is this. It's an amplitude is just half. It's from the middle to the top of one of the peaks. You also need to be able to label the wavelength, which is the distance between one wave crest and the next. And that's measured in meters even. Now a crest is just a peak or a trough of the wave. So this here is called the peak of the wave, and that's a crest. And this here is called a trough. Now you can see why the trough is called a trough, because it looks a bit like a trough that animals might eat from on a farm. And a peak is a peak because it's the top. So this distance between one trough to the next trough, or one peak to the next peak. So this is wavelength. Or this is wavelength. But it is not that, because that's half. Okay? It's not that. It has to be specifically from this point to this point. If you draw a line that's a little bit down, say from there to there, you will not get the mark. So the really important things to know: the wavelength is from there to there, the amplitude is from there to there. Now the final thing to know about in terms of describing a wave is the frequency. You can't draw this on a wave. If you think what the word frequency means, if you say what's the frequency of a bus, someone might say, oh, you get 6 an hour. So frequency is 6 per hour. Now in physics, frequency always means something per second, and for waves, it's the number of waves that pass a given point per second, and it's measured in hertz, okay, which is not just a car company for rentals. Hertz was someone who did a lot of work on waves, and he's been recognised by having this unit named after him. So frequency is the number of waves that pass a given point per second. If you think about it like a bus, if 100 buses passed you every second, the frequency would be 100. So each of these peaks was a bus, then it would be 100 per second, or 100 hertz. If there are only 50, it would be 50 per second, or 50 hertz. Now, it's really important to not get confused between these things, but they are related, apart from amplitude. Amplitude isn't really related to the two. Now, amplitude, this is what volume depends on. Okay, so if you turn up the amplitude of something, like on an amp, if you ever play the guitar, you're turning up the volume. And all you're doing there is that you may have had a wave that was like this, but now the wave has got a bigger amplitude. You're not changing anything else, okay? Now, wavelength and frequency, they're related by wave speed and the wave equation, which we're going to do in the next page. These, frequency especially, are to do with pitch. So to have a higher frequency means you have a higher pitch sound, so a higher sounding note. So if we think about wavelength and frequency one by a term, so wavelength, if I've got a small wavelength, it would look like this. If I've got a longer wavelength, it would look like this. Now, it doesn't need to be bigger. It is a little bit, because you always seem to automatically do that when you write. This is the short wavelength, and this is the long wavelength. For frequency, you'll see it kind of works the other way around. So something like this, depending on the wave speed, if it had the same wave speed, would have a lower frequency compared to something like this, because if this was travelling at the same speed across the page, more of these peaks would pass per second. So frequency is just the number of waves that pass a given point per second, and wavelength is just the distance between one wave crest and the next. Now they're related by something called the wave equation. And this might be the first equation that you came across in your physics GCSE. So the wave equation just relates these three things together. So relates these together. Okay, it relates frequency and wavelength that we just talked about, and wave speed. And wave speed is simply this, the speed at which the wave moves through the medium. So if you've got a slinky, it's how quickly that wave moves along the slinky. If you've got water waves, it's how quickly those waves are travelling through the sea. Now, an easier way to write this, if you're writing it out lots of time, is using symbols. And the symbol for wave speed is V. The symbol for frequency is F. And the symbol for wavelength is something called lambda. Okay, it's a Greek letter. So V equals F lambda. Or if you like it in words, wave speed equals frequency times wavelength. You'll be given this equation in your exam, but you need to know how to use it. Now, if we think about the units of each thing, we know that frequency is measured in hertz. We know that wavelength, being a length, is measured in meters. Now, wave speed is just like a normal speed. It's measured in the same units as speed. And that, in physics, is normally meters per second. That's what that means. Meters per second. Now, we can draw this in a triangle, because sometimes people like to use triangles instead of rearranging. So if you want to ever draw, if you have an exam question that needs you to rearrange this and you don't want to, you can think about it in a triangle. And your triangle will look something like this. It will have wave speed at the top, so V at the top, equals frequency here, wavelength there, with a little times there and a divide there. Now, I'll show you how to use the triangle in a second with two example questions. Now, our first example question is this. A wave has a frequency of 50 hertz and a wavelength of 10 meters. What is the speed of the wave? If we look at the bottom, we have our equation. Wave speed equals frequency times wavelength. So we don't have to rearrange this equation. It's already in the right form for us because we've got wave speed on its own at the side. However, I'm going to show you how the triangle works really quickly. So V equals F times lambda. That's divided by. So I want to know the wave speed. So what I do for the triangle is that I cover up with my finger the one thing that I want to know. So I want to know the speed. So I cover up V. And then what's left, hopefully you can see, is the sum I need to do. F times lambda, frequency times wavelength. So, thinking about this, I'm going to write that out for me. V equals F times lambda. And then I'm going to sub in those numbers. So V equals frequency, which is 50, times lambda, which is 10. So V is just equal to 50 times 10, which is 500. And I must remember my units, so meters per second. This is really, really important, those units. This is an amazing way to lay out your problems, because then, if you did something wrong, if you said maybe that 50 times 10 is equal to 1,000, obviously it's not, but if you did, you could still get a mark for doing this section. So if you just wrote 500 metres per second, you'd get full marks. But if you wrote the wrong number, even though you knew what someone was doing, you just made a mistake, you wouldn't. So it's really important to lay out your equations like this so people know what you're doing. The next question is a little bit harder because you need to rearrange it. So a wave has a wavelength of 10 metres and a speed of 340 metres per second. What's the frequency of the wave? Now if you look at this here, this isn't in the right way for us to use. Wave speed equals frequency times wavelength. Frequency is not on its own, it's in the middle of the sum. We need to change that. Now, there are two ways to do that. The first thing I'm going to show you is using just simple algebra as in maths. So V equals F times lambda. Now I want to get F on its own, so I need to move lambda. If I multiply by lambda on this side, I have to do the opposite on this side. So all I need to do is divide by lambda to move it over here. Therefore, I get F equals V divided by lambda, there. And then I can just do my equation, which I'll show you how to do in a second. However, you might want to use the triangle instead. If you want to use the triangle instead, if I draw that really quickly back up again, V equals F times lambda. I know wavelength, which is lambda. I know speed, and I want to know frequency. So I cover up frequency with my finger. And then I see that my sum that I need to do is V divided by lambda, which is exactly what I've got here. Okay? So this is the sum I need to use. Frequency equals wave speed divided by wavelength. I spelled that wrong. No, I haven't. Excellent. So I can just sub this in now. Equals frequency equals wave speed divided by wavelength. So equals wave speed, which is 340 meters per second, divided by wavelength, which is 10. And from that, I can get that equals 34. And then I really need to remember my units, which is hertz. So That's how you do that kind of sum. If you had an equation that asked for the wavelength, when you need the wave speed and the frequency, you would do exactly the same kind of thing. You'd rearrange it, you'd cover up your lambda, and you'd do v divided by f. So hopefully that makes sense. It's really important that you know how to use this triangle or to rearrange equations. Either one, it's up to you. And you can use that equation that will be given to you, because it's a really easy way to get some marks. You don't have to remember anything, you just have to remember how to do something. So that's the end of P1. Hopefully it's helped. And if you need help with P2, etc., there'll be more videos on those coming up soon.